Yes, Nehra.
Sir, was it a reaction function?
क्या reaction? ये आप तुक्का क्यों मारी? You can look at your notes ना. You don't have notes. Tell me. Do you have notes? Yes or no? Hey, you don't have a chemistry notebook for the classes?
Sir, yes, sir, I have notes.
So look at na, what was the last thing that you wrote on that notebook? Yeah, you write all the notes in the same notebook. That's really messy. जल्दी बताइए नहरा.
Sir, it was reaction quotient.
Reaction quotient. अच्छा, तो आप यानी कि you were not present or what? Huh? It's obviously not reaction quotient. Reaction quotient ये इसका इनका था क्या? Okay. So you were not present on. This is the last thing that you wrote. What was the last? You नहीं लिख रही हैं आप ठीक से notes, हाँ नहरा?
Sir, I'm writing.
नहीं, आप नहीं लिख रही हैं ठीक से. Send photo to Nishkar sir. Last page that you have written. Send the photo. This is not good, huh? It's not good now. Assalamu alaikum Fahim. How are you?
I'm fine, sir.
You were not present on Tuesday and Thursday, I guess.
Sir,
Imran,
I'm very sick.
You're very sick.
Yes.
What happened?
I have cold, flu, cough, headache.
Did you get yourself checked?
Yes.
Taking medicines?
Yes.
Okay. Is it Omicron or
No,
is
no,
it
no. It's
Corona?
nothing like that. It's nothing. Weather change cold. Because here it went foggy, raining.
Yeah, it must be raining because yeah.
Yes.
I mean, we are quite near if I talk because I'm in Jharkhand, which is then we have Bengal and then we have Bangladesh. You are still in Bangladesh?
Yes, yes. I'm going next week.
Next week. Did you get your examination date?
Yes, my exam is currently going on, but I have to give a test next. Like when I go Kuwait, then I have to give test.
Acha, yeah, exactly correct. Imran told me the last class on Thursday, I guess, that your examinations is going on. So
Yes.
how does this work? You can give examination.
I basically, before coming, I gave them a letter that I will be having off for a month, and they first didn't allow me, but then they allowed me by saying that exams are on February, not on January. So I came,
Okay.
and now they just shifted from February to January.
Oh, okay. Yes, Nehra, I'm waiting. Nehra, did you send the photo? Yes, Nehra, did you send the photo of your notebook?
Yes, sir.
Why not?
Yes, sir.
Oh, yes, sir.
Sir,
क्या ठीक से? Yes, yes. Tell me what happened. अरे please send it fast and tell me ना. I can't wait like this. आज भी तो पढ़ाना है.
Sir, I sent.
अच्छा, you have sent. Okay, fine. You have sent in which number? 931. 93102.
Yes, sir.
Okay, fine.
Yes, sir.
Okay. Is my voice lagging? I'm really sorry if my voice is lagging. Okay, fine. I think I can start. I can start the class. I will get your photo. अगर आप नोट्स नहीं बना रही होंगे ना, फिर देखिएगा आप पता नहीं क्या ही दिया है आपने रिएक्शन कोशेंट. That is the last thing that you have wrote. You have not written this. Characteristics of equilibrium constant. ये बताइए आपने नहीं लिखा है, नहरा? Nehra, Nishkar sir is saying that you have not sent the fit photo. Is it getting uploaded? क्या हो रहा है?
Sir, maybe the network issue. Only one tick is there.
Can you tell me the phone number? 93102-84958.
Yes, sir.
Okay. That account is currently active. I just had a chat. Okay. I will get it then. Okay, fine. If you have sent it, then I will get it. Okay. Fine. So now in this, before the characteristics of equilibrium constant, we were learning about the application of equilibrium constant. In that, we had to learn the last, that is the calculation of equilibrium constant concentration, equilibrium concentration of reactant and product. Okay, so let me start my class today. Now, this is under the topic of calculation of equilibrium concentration, calculation of equilibrium concentration. Now, again, I will emphasize on the point that I always talk about. Whenever we are going to equilibrium concentration, so it is something quantitative, yes or no? It will have some number. A concentration, if I talk about concentration, it will have some number, yes or no, guys? What happened? I'm asking simple thing. If I am going to tell the concentration of a particular substance, then I will be uttering from my mouth some numbers, yes or no?
Yes, sir.
Okay, no doubt in that. Okay, fine. Now, whenever I have to tell something in terms of number, very quantitatively, then there are only two methods that can be done with. I can either measure it, or what I can do. What is the other thing that I can do? Yes, very good. Or we can calculate. So for measuring, what do we need? We need a device. Yes or no? And calculation, for calculating, we need some information, some data we will be needing, because for example, let us take for volume. And I started with volume. So for volume, I need the length. So for length, I need again a device. But so we will be needing some data we will be needing. And some data which can be measured, with a very cheap device, and there will be some formula that I will be needing. I'll be needing some formula. Okay. Now let us see for equilibrium concentration, which is more feasible. For example, we discussed about volume. What is more feasible? To calculate the volume rather than measuring the volume. We can measure the length. That is more easy for us. We don't want to calculate the length, right? We will measure the length by a ruler, by an inch tape or something, measurement thing. And then we will measure the length, breadth, and height, and then we can calculate by using the formula a cube if we have a cube, and we can calculate the volume. So we needed some small data, very cheap data. I can see we need some cheap data and a formula which can help us to calculate something. Now for equilibrium concentration, let us see what can be done. So now moving on to the real case. In real case, what do we have? We have a jar, a container here. In this, we added A, and we also added B. So we added A plus B. Now what I'm seeing that I'm getting C, but this is a equilibrium concept. This is a equilibrium reaction, reversible reaction. That means there will be some amount of A and B present inside the container, and there will be some amount of C also present. So we'll rather in the container, we'll have a mixture of A, B, and C. Now I want to know what is the concentration of C, what is the concentration of A, and what is the concentration of B. I want to know the concentration of all of these reactants and the product, the equilibrium concentration. At equilibrium, what is the concentration? Now, for this, first of all, what I have to do is, first of all, I have to separate A, B, and C, right? First of all, I will have to separate. So the separation will need a device. Okay, separation will need a device. Then next thing that I have to do is, whenever I have separated A, B, and C, then I have to measure it, all of them, right? Measure the, let us say we have separated and these are solid, we have made it to solid, then we will measure the weight, and then we will divide that by volume, and we will get the concentration, right? We will get the concentration. So this is something. So we need a device for separation, at least. We need a device for separation. Now let us see what we can do if I want to calculate. Okay. So for calculation, what do we need? We have a reaction like this, A and B. Okay, A and B. And let us say that we have the equilibrium constant. This reaction was done earlier. And we have got the equilibrium constant. That is, let us say it is equal to 1. That is equal to 1. Now, in this case, what I can say that this equilibrium constant, it is equal to 1. It represents that concentration of B upon concentration of A. What does it represent? For each mole of A, there is 1 mole of B. All of you know, yes or no? For each mole of A, there is 1 mole of B. Yes?
Yes, sir.
Fine. Now let us say that I initially started with 10 molar concentration of 10 molar of A. Initially, I took 10 molar of A was present. Then, now since this is a very easy reaction, you can obviously say that at equilibrium, we will have 5 moles of each. Yes or no? Can you see that happening? Because 10 moles of A will convert to B. So you will have, let us say, A and B were there like this. So initially 10 moles, and this was 0. Then it became, the reaction will move towards B because A is more, and you will get 1 mole of A. Then you will, again, reaction will still move towards B. Reaction will still move towards B. Now when they are in 5 and 5, now the reaction will stop. There will be no forward or back. There will be forward and backward reaction, but on the same rate, because I have achieved the equilibrium concentration, that is 5 upon 5, which will be equal to 1. All of you got this, yes or no?
Yes, sir.
Okay, fine. Now let us standardize this thing. Let us generalize this thing. We cannot always write this much now. And always the equilibrium constant will not be so simple 1. And neither the reaction will be so simple that 1 mole of reactant is giving 1 mole of product. There will be multiple reactant. There will be, the stoichiometry will also be different. So let us just generalize something. Let us see how can we make a series of steps that will help us to calculate the equilibrium concentration. Now let's write like this. There is A and there is B. Okay. So I will write initial concentration of A was 10 molar and the B was nothing. Initially B was nothing, it was 0. Now the reaction, I know that what is happening, A is getting converted to B. So there will be some change. So this is initial, this is change. There will be some change. Now since A is getting reduced, I don't know how much it is getting reduced. Okay, I don't know how much it is getting reduced. So since it is getting reduced, I will see that the change is minus X because I am deleting some of A, and X because the amount of change is unknown. Can I write minus X? All of you understood this? Why I wrote minus X?
Yes, sir.
The minus sign, it signifies that A is getting reduced. X signifies that I don't know what is that change, how much A is changing. Okay, but for B, if I ask you, if 1 mole of A was converted, to B, how many B would be made? If I look at the reaction, how much B would be made? If 1 mole of A was consumed, for each mole of A, how many moles of B will I get? Look at the reaction and tell me.
Half.
Think about. Yes, समझा?
Half.
नहीं, initially नहीं बोल रहे हैं हम. Initially, let us say ना, यहाँ पे देख के आप बताइए. You see here and tell me. 10 to 9, the change was of minus 1,
Minus -1.
and here it was plus 1.
Yes, sir.
So what will be here? In this case, plus x. Yes or no? Because if x moles of A got converted to B, then B would have x moles. Yes or no? There will be, because you can see the stoichiometry,
sir.
1 mole of A is giving 1 mole of B. Hai 1 mole of A is giving 1 mole of B. Okay. Now see, initial and then change. Now what I can say that this was the change in the complete equilibrium process. Now, after this change, I will write the equilibrium. So this will be 10 minus x, and this will be x. What is this? The equilibrium concentration. What is this? The equilibrium concentration. Okay. If these are the equilibrium concentration, then I can say that the K, it is equal to the concentration of B divided by the concentration of A. And also I have the K, which is equal to 1. And I also have B, which is equal to x from the table. And then A is 10 minus x. Now I just need to find what is the value of x. So I can write 10 minus x, it is equal to x. And hence I can write 2x, it is equal to 10. And x is equal to 5. Okay. Now we have standardized fun formula. And in this case, we see that this table is very important. This table is very important. And we will call that, this is the ICE table. Hai na? This is the ICE table. Initial, change, and equilibrium. Initial, change, and equilibrium. Initial, change, and equilibrium. Now we will get the equilibrium. We'll write equilibrium in terms of one variable. We will write equilibrium in terms of one variable. And then what I will do, I will substitute that in the expression of equilibrium constant, in the expression of equilibrium constant. Now let us devise some different cases in which we can write the change. Okay, the change is important. So we looked at A giving B. We looked at A giving B, right? If I write the initial, there will be some initial. Okay, if this was 10 initial and this was nothing, the change will be of minus x and this will be plus x. Okay, now if I write 2A giving, rather let me start like this, A giving 2B, then if I wrote initial was 10 here, the change will be minus x, but the change for B will be plus 2x. Yes or no? Tell me, guys. Because for each mole of A, I'm getting 2 moles of B.
Yes, sir.
Okay. Now, if I had A plus 2B giving me 3C, then in this case, I will write, if the initial, let us say the initial is 10, 10, and nothing, then for A, I will write, minus of x. For 2B, I will write minus of 2x, because in each reaction event, once the reaction is going, 2 moles of B is consumed, and we are getting 3 moles of C, so plus 3x. Any doubt in these cases? Yes or no? Tell me.
No, sir.
No? Okay, fine. So this is important. You will write this. Okay. Because in this, we have written all the changes. So the changes are important. How to write the change? Because that will be represented in the equilibrium. Okay. Write this down. Let me know if you're done. Done, guys? Yes, done.
Yes, sir. Done.
Done. Okay, fine. Now you will write a question. Okay, so you know how to calculate. And we also know why do we, okay, now you can see that we can calculate the equilibrium concentration without any device, right? So that device which was used for separation, is quite expensive. So we will be using calculation rather than measurement. So equilibrium concentration will be calculated and not measured. Okay, it will not be measured. So because we have a formula which is quite easy, simple 11th class student can also calculate it. If we have the Kc given, something from the equilibrium should be given, some information should be given. So this is the question. You write this question. Then we will discuss the solution. So I'm writing the reaction first of all because we need to make the ice stable. So we have carbon monoxide gas plus H2O gas. It is in equilibrium with carbon dioxide gas plus H2 gas. Okay. Write the initial. There will be change. And then we will be writing the equilibrium. Done? Yes or no?
Yes, sir.
Okay, fine. So you tell me initially what is the concentration of CO? What is the concentration of CO given? Carbon monoxide.
4.24.
Please read and tell.
Oh, okay. Sorry, 800.
अरे पढ़िए, सवाल पढ़िए, नंबर क्यों पढ़ रहे हैं आप हमजा? Read the question.
$0.10.
एकदम ऐसे नहीं चलेगा काम. You have to read the question, okay? Just don't pick any number. What is the concentration of H2O? What is the concentration of H2O initially?
0.10.
Yeah, 0.10. बाकी आप लोग को दिख रहा है? नेहरा, हिबा, फहीम. What is the concentration of carbon dioxide initially? Okay, what is the concentration of carbon dioxide initially?
Sir,
हाँ, Fahim.
can I leave?
You want to leave? Why? You're not feeling well?
No, sir. I am having a headache.
Okay, fine. Take care.
Thank you so much, sir. Bye, sir.
No problem. Okay, bye-bye. Yes, what is the concentration of CO2? What is the concentration of CO2?
So you have to calculate that.
Initially बताइए ना. Look at the question.
0?
Yeah, 0, because they are saying na. See, Hamza, please read the question na. Read it out loud. अरे read ना.
Yes, sir.
हाँ बोलिए जी.
1 mole of CO gas plus.
अरे read the question. आप सुन भी नहीं रहे हैं क्या? Read the question. क्या हो गया है हमजा? पानी वानी पी के आइएगा. क्लास थी क्या आपकी? यस हमजा.
Yes, sir.
हमने क्या कहा आपसे? What
You have
to?
to read the question.
हाँ, so read the question ना.
Like from the calculate part.
नहीं KC से स्टार्ट हो रहा है ना क्वेश्चन तो.
Okay, sir. KC for the reaction, 1 mole of CO gas plus 1 mole of H2O gas gives 1 mole of CO2 gas plus 1 mole of H2 gas
Very
is
good.
4.24 at 800 K. Calculate the equilibrium concentration of CO2, H2, CO and H2O at 800 K. If only CO and H2O are present initially at concentration of 0.10 m each.
Okay, now you tell me what is the concentration of CO2 according to the question. Initially.
0.
Yeah, 0. So this is no CO2 is present and no H2 is present. Okay. Now I will write the change. What should I write the change? Minus, because this is going to be decreasing, because we don't need to compare the QC and KC. Sometimes you will be given some of the concentration of product also. Then you have to calculate the QC and then you have to decide yourself the reaction will be going backward or forward. Now I can easily say that since we only have the reactant side, that is the left hand side, that means the reaction will be going forward. So in this case, I can write the minus X, right? The change will be minus X here. Yes or no?
Yes, sir.
For H2 also minus X. because 1 mole of CO, 1 mole of H2, and the ratio here is what? Here it will be plus X. X moles of CO2 will be formed and X moles of H2 will be formed. Any doubt, guys? Tell me. Any doubt,
No,
guys?
sir.
Yes or no? No doubt. So equilibrium will be 0.1 minus X. This is the number of moles of carbon monoxide. 0.1 minus X. This is the equilibrium concentration of H2O. This is the X is the equilibrium concentration of CO2 and X is the equilibrium concentration of H2. Now I can write the K because I have the equilibrium concentration with a single variable. Now we have the concentration of CO2, concentration of H2 divided by the concentration of CO and concentration of H2O. Now for CO2 and H2, I know that the concentration is how much? X into X divided by 0.1 minus X to 0.1 minus X, and the K that they have given is 4.24. Now all of you can see that it is going to be a quadratic equation. Let me just write a few things more. 4.24, which is equal to X square. 0.1 into 0.1, 0.01 plus X into X, X square minus 0.2X, A minus B whole square. Okay, now you can see that this is a quadratic equation. If you don't know what is the quadratic formula, please write the quadratic formula. ये पता है कि नहीं quadratic equation? Have you seen this 10th के बाद अभी? हाँ?
Yes, sir.
You have seen this, no? Okay. Minus B plus minus root under B square minus 4AC divided by 2A. Okay, divided by 2A. So write this down. This is the. हिबा आपको याद है ये? आपका बायो है ना? लिख लीजिए आप. Now you need to calculate the X. चलिए. So equilibrium ऐसा ही है. It's easy if you understand, if you like थोड़ा सा, if you put an effort in the theory, you can understand the theory part, how it is all working, why we are getting the equilibrium concentration, why we are calculating it, why we are not measuring it. You'll understand all of these things. But quadratic equation, you have to move your hands, है ना? You have to calculate these things. थोड़ा patient होके, है ना? Please calculate. I hope you don't take much time. यहाँ पे you would really hate ICSE school student. They can use calculator, and with calculator it becomes very easy. Yes, guys. No luck. So what would be this? Let me just write x square here. This will be 0.0424 and plus 4.24 x square minus 0.848 x 0.42. So yeah, x. What I can do, I can just get all those things here. I can write, let me take x there, and this will be 0 is equal to 0.0424 plus 4.24 x square minus x square minus 0.848 x. So this x square, it is here, okay? And we have changed the sign. So it will be equal to 0.0424 plus 3.24 x minus 0.848 x, 0.848 x. Now, you can write that we should arrange this in a better way. This will be x square first, 3.24 x square minus 0.848x plus 0.0424, right? It's equal to 0. Now I hope you guys know what are A, B, and C. This is our A. And this is going to be our B. And let's see. This is our C, right? A, B, and C. Now I can write X. It is equal to, you can write this is A, this is B, and this is C. So what is A? So what is B? Minus of 0.848, right? This will be plus, because we have minus of minus, this will be plus 0.848. Okay, then we will have plus or minus, right, both here. Then we will write what is B square, 0.848 whole square. Okay, 0.848 whole square minus 4 into A, that is 3.24, into C, that is 0.0424, divided by 2 times A, 3.24. Okay, now in this case, what you need to do, first of all, you need to calculate the square. Okay, first of all, we will be calculating the square, then we will be calculating these two numbers. First of all, 0.848 square, and then 4 into 3.24 into that. So you don't calculate like this, you just make a line like this, and then you write 0.848 whole square. It is equal to how much? Did anyone calculate this? Did anyone calculate this? Yes or no? Hamza, Hiba, Khalid, Nehra? No. Can you please say, at least say yes or no? Then I will move on. Or otherwise, I will tell you to calculate this.
I was calculating this.
You're calculating it. Okay, fine. So you will calculate that first. Then you will calculate. So please don't write x is equal to like that. Okay, please separate now. Make a line, because these are many things are happening. Okay, so you have to break it down. Please break it down. Otherwise, it will be very exhaustive for you. Then you will calculate 4 into 3.24 into 0.0424. Okay, so Hamza is calculating this. Wait a second, don't write anyone. Hiba, did you calculate this? The square? Yes or no, Hiba? Okay, then you will calculate the next number. Okay, so let Hamza calculate this part. Okay, same goes with Nehra and Hamza. This is for Hamza, and Nehra will calculate this. Hiba and Khalid will calculate this. Okay, please calculate this and tell me the answer in the chat. Okay, I have got one answer from Khalid, and I think that is kind of correct. Yes, that is correct.
Sir, I took like different value.
Different value? What do you mean different value?
Solving.
Huh?
Like the equation I further divided by 4 to get a smaller number equation.
No, I did not understand. What did you say?
I divided the equation by 4
Why?
to get
Which
the
equation?
more smaller number.
More smaller number.
Yeah.
Okay, and then what happened?
Then I did the quadratic equation formula.
Okay, so you have got whatever, I mean, you have calculated this now.
Yes, sir.
It is the same number. It is the same number. I think if you multiply this, then it is also the same thing. Hamza, I have
Sir,
seen your answer.
up again.
Yes. Sorry?
Could you scroll up?
Yeah, I can scroll up. Till where, but
Yeah, below the equation. Yeah, okay.
yes, Hamza, that is correct. I'm waiting for Hiba and Nehra. Nehra, are you there? Waiting for Hiba and Nehra.
Sir, I have sent the answer.
आपने किसको भेजा? Sorry, just got it. Okay. I missed this. I don't know how. What about Nehra? Nehra, are you not there? Nehra is not attending the class. It seems like that. Okay. Yes, very good, Nehra. Thank you. So the square was, I can write that it is 0.72 and this is equal to 0.55. Any problem with that, guys? No, na? Tell me. No, na.
No, sir.
0.7 to 0.55. Now this is, I need to subtract these two things, right? So what will be the subtraction if I subtract these two things? 0.17, I guess. 15 and 17, yes. 0.17. Yes or no? 7 5 12 का 12 2 हाथ में 1 7 5 12, yeah. Yes or no?
Yes, sir.
0.17. Then I need to take the root of 0.17, right? Yes or no? Because there is a root here.
Yes, sir.
Okay, I need to take the root. So see, this root is going to be a bit difficult for you guys because 0.17 ka root kaise le? So what you need to do is 0.17. 0.17, what is the nearest thing? I can say that this is 0.17, na? 0.17. Then obviously I can say that this is equal to root of 17 upon 10. Yes or no? Tell me, guys. Yes or no? Under root 17, under root. Can I write this as? Tell me yes or no. Arey, what happened? Achha, you can say yes or no. Either way, I will prove it. I don't think you guys agree. Do you guys
No,
agree?
I don't think so.
You don't think so? Okay, fine, no problem. Fine. Okay. So, but I will start with like this 0.17. So I don't know what is 0.17. I don't know how to deal with it. Does anyone know here knows here how to deal with this? Tell me. Do you have any idea like how to calculate this? Root of
I think
0.17.
instead of 10, it should be 100.
Instead of 10, it should be 100. Okay, I understand where you are coming from. Okay, but still. So what I will do, I will say that let us figure out hit and trial. Let us figure out by hit and trial. So I know that the nearest perfect square is 16. The nearest perfect square is 16. If I talk about this number 17, then the nearest perfect square will be
Yes, sir.
16. And the root of 16 is equal to 4. So if I talk about root of 17, this will be somewhere around what? 4.1. Yes or no? Because we have just increased one number, na?
Yes, sir.
I can round it off to 0.1. And it will not be, obviously, it will not be 0.4.2 because 4.2 will be much greater than 4.2 into 4.2, it will be much greater than 17. Okay. Now what I can say, let us try this. 0.41 into 0.41. Okay. Multiply these two now and tell me what is the answer.
Nearly 0.17.
Nearly 0.17.
Yes, sir.
Right. So can I say that what I did? 17 divided by 10 divided by 10. Yes or no? So I can write now 0.17. You now figure it out. That why is this okay? Okay, Hamza. In next class, we will figure this out. Okay. How 0.17? It is equal to root 17 by 10. Okay.
Yes, sir.
I don't know. I think you guys should see this, na? Wait a second. Let me show you. So this I can write as the whole root of 17 upon 100, which will be root 17
Yes, sir.
upon
Understood.
10.
Yes.
Understood, na? Okay. Chalo. So you have the root also now. You have the root also now. Now what I can do? I can simply write this as 0.848 plus minus 0.41 divided by 2 into 3.24. So you calculate this and tell me what is the answer. Calculate this and tell me. अच्छा, wait a second. यहाँ पे प्लस लेना है या माइनस लेना है, तो प्लस लेना है पहले, ना उसके बाद माइनस ले लेंगे. Just tell me the answer for this one. So whenever you get a quadratic equation, please you first of all calculate the square, then the 4ac, and then subtract them, then calculate the root, and then plug in the values. Okay, don't try to do everything at the same time.
0.194 for the question.
Approximated to 0.194. Okay, did anyone else calculate this?
0.194.
0.19 for both of you. Okay.
Sir, in the minus side, it's 0.073.
0.073.
0.0673.
6 would be, I think, yeah, 0.067. Just 0.067. Okay. Now we have got both of the values can be valid, right? Yes or no? Tell me. Guys. We have calculated x. अरे भूल मत जाइए, equilibrium चल रहा है, quadratic equation नहीं चल रहा है. Okay. What is this x? The change, right? Yes or no? We have calculated
Yes,
the
sir.
change. We have calculated the change. So the change, they are saying that according to the quadratic equation, it has two values, either 0.194 or 0.067. Now we have to choose one now, because the change cannot be two numbers. It will be only one. The x will have only one valid number. So now let us look back and let us write which of that will make sense. Can I write here 0.019? Tell me. Yes. Tell me, guys. Can I write here 0.019?
No, sir.
Why?
That's because the number is getting large.
Yeah, it is not possible. From 0.1 molar, I cannot react 0.019, right? So the x that I will take will be 0.067. All of you understood this? Because whatever change will be either equal to, it can be equal to the initial concentration, but it cannot be the greater than the initial concentration, right? The change, I will say that x, so x, it is equal to 0.067. Okay. Now in your school also, it will not matter. Okay. You just write like this, whatever, how we have solved this now, just solve like this, no problem. They will see, now this is more clearer than writing all of the steps. X is equal to itna, thoda sa usme mein you will solve something, it's not good. Separate everything and then write it clearly in the same page. No need to write all of these things in the back page also. In examinations, to please make sure that you're writing all the things here only, but it should be clear, it should be clean. Don't make it dirty, it should be clean, and you can put that in the fair thing only. Don't write in the back page. It's good when teachers see these calculations now, so they are impressed and they are like, okay, fine, he does this calculation, he's not looking here and there while calculating. Okay, x is equal to 0.067 and x, okay, we will write here full stop. X is equal to 0.19 is neglected or ignored. Okay, now we have got x is equal to itna. Then we have the concentration of CO2, which is equal to the concentration of H2, right? Which is equal to what? Which will be equal to 0.067 molar. And the concentration of carbon monoxide will be equal to the concentration of H2O gas, which will be equal to 1 minus, let me write it like this. This is equal to x, and hence it is equal to 0.067 molar. This will be 0.1 minus 0.067. This will be equal to how much? 0.033 molar. Yes or no? You all understood this? Yes or no? Tell me. These are the equilibrium concentration. Hai ki nahi?
Yes, sir.
All of you?
Yes,
Okay.
sir.
Copy this down. Let me know if you're done. Okay, Hiba is done. Those who are done, they can write this question. Let me know if you're done writing this question.
Yes, sir. Done.
Done. Okay, fine. Now, please read this question. Read this question. Not out loud, but read this question once. See what is given, what is not given, what they have asked us to calculate. Okay. So now let me tell you. Whenever you have equilibrium question, in which you see something that calculate Kc, Kp, partial pressure at equilibrium, I know. So in any question of equilibrium like this, where you have to deal with the reactions and all, you please try to think in these terms. You have initial. There is some change. This is not a reaction. Okay, this is not a reaction. This is just, you can say that, sequence of events. So initial, there will be some change, and then you will be getting to equilibrium. And a good question will always ask something about the equilibrium. Okay, it will be given, the initial will be given. You can see that there are three variables in this equation, right? We have initial, and we have the change. Initial, and we have the change. And we also have the, and what else we have? We have the equilibrium. We have the equilibrium. Wait a second. Yeah. Now, the initial, it will be given in the question. Or it may also be asked, but I'm talking about a good question, because initially, I mean, if you are asking something about initial and you are asking the students to calculate the initial concentration, then that questionnaire is not a good questionnaire, because you can easily measure the, right? You can easily measure whatever reactants you are taking. You don't need to calculate that. So initially, it will be given in question. The change, you can write about the change. It will be a variable. This will be done according to the reaction. Okay, so for this, you need a reaction that is balanced reaction. Okay, you need a chemical reaction that is balanced. Now, for equilibrium, we can have many things. Okay, now this initial, it can be given as concentration, and it can also be given as number of moles. It can also be given as mass, but all of these can be convertible, right? The basic thing that they can give is grams. Then you can convert this to moles. Then you can convert this to concentration, right? You can also convert moles to pressure, right? Because PV is equal to nRT if you use those things. So if you have been given any of these things, you can go around and calculate any of the initial things in terms of concentration or pressure, because we write Kc and Kp in terms of concentration and pressure. Now, for equilibrium, I can say that there are two things. If you may have only gases in the reaction. Now, if you have only gases in the reaction, then there are three things that can be given to you. Okay. They can directly give you the Kp. They can also give you the Kc, and they can give you the P total at equilibrium. Okay. Now, please remember that initial and change. If I do initial minus change, it will have some relationship with the equilibrium thing. If you have gas, okay, this if you have gas. G means if you have gas. Let me write that. Otherwise, you'll be thinking this G is gas. Sorry, this G is gram. It's not gram. I need to reshare this thing. Okay, so if you have gas, then they can give you P total at equilibrium, Kp or Kc. But if you have anything else other, then they can only give you Kc, or they can also give you concentration of one product. Okay, and by the concentration of one product, you can infer about the concentration of other products. Fine. Now, in this question, you can easily see that you have been given the initial. You can always refer. You don't need the questioner to give you the change. You have the reaction, and from that, you can also get the change. And in this, they have given the P total at equilibrium. Yes or no? Tell me. You have all the things that are needed, right? A P total at equilibrium, you will have initial and change. If you get the change, then you can easily calculate the Kp, you can easily calculate the Kc. Don't worry about that. But can you identify what is given, what is not given? Yes or no? Tell me first of all that. Hamza, Hiba, Khalid, Nehra. You can see that initially N2O4 is present. N2O4 was placed in 1 liter. So they
Yes,
have given
sir.
mass of N2O4. They have given the change and the changes in this reaction. And they have given the total pressure at equilibrium. So they have given something about the initial, they have given something about the change, and they have also given something about the equilibrium. Now you need to just calculate what exact is the change. Okay, what is the equilibrium concentrations, pressures, and anything in different things. So for this, we will do this question. Don't worry about that. Okay, we'll do this question. So please write. First of all, you will calculate the number of moles of N2O4. Then you will calculate the pressure. So as we know, the number of moles will be equal to N2O4. It is equal to the given mass divided by the molar mass. Okay, divided by the molar mass. So the given mass is how much? 13.8 gram. No, 13.8 gram divided by molar mass is what? Nitrogen 2 and oxygen 2, 92 grams per mole. Okay, so this will be equal to 0.15 moles. So you have number of moles, then you can write PV is equal to nRT, and here pressure, it will be equal to nRT divided by V. So number of moles is 0.15. You can take the RS. You can take the RS 0.0831 liter ATM per Kelvin per mole. 0.0831. Why I'm taking 0.831? Because it is bar. So 0.831 will be bar, not 0.0821. You have to take 0.0831 because I have mentioned in the previous class that R you should take in terms of the unit of pressure times the temperature. Temperature is how much? They have given 400 Kelvin. So you can calculate the pressure into 400 Kelvin and divide by 1 liter. So you don't need to write 1 because that will be just useless. So please calculate the pressure and tell me what is the pressure, the initial pressure. Yes, anyone? What is the pressure, guys? The initial pressure? Yes, Hamza, correct. Can somebody please confirm this number? 4.98 bar. Khalid, Hiba, or Nahra? Anyone?
Yes, that is 4.98.
4.98 only. Okay. So we have got the initial. Okay, we have got the initial in terms of pressure. We will first of all calculate Kp, then we can calculate the Kc. Okay. Now, if you want to go the other way, that is also fine. What you can do is you have the 0.15 now, 0.15 moles, and obviously because if I want to calculate the concentration of N2O4, what is the concentration of N2O4? N2O4. Concentration of N2O4, and I can write that this is equal to 0.15 divided by 1, right? Which is equal to, because 1 liter now, 0.15 only. So you can take any of these things and then you can calculate either Kc or you can also calculate Kp, whatever you like, Okay. Now, first of all, we need to write the equation. We have N2O4 gas, which is getting dissociated, and it is forming 2NO2. We have initial, change, and equilibrium. So initially N2O4 is how much? Initially N2O4 is how much? 4.98 bar.
4.98.
Yeah, and NO2 is nothing. Change will be minus X. What will be the change here? What will be the change here? If
Plus
X is
2x.
getting, yes, plus 2X. So the equilibrium will be
Plus 2x.
4.9. Yes, correct. 4.98 minus X and plus 2X. Okay, plus 2X. Now, this is what? This is the pressure of N2O4 at equilibrium, right? This is the pressure of NO2 at equilibrium. Pressure of NO2 at equilibrium. And we know that Kp, and we can only go with Kp because we don't have Kc. Otherwise, it would be fine. We can only go with Kp, not Kc. So Kp, it will be equal to concentration of NO2 whole square divided by the concentration of N2O4. Okay, the concentration of NO2 is how much? 2x whole square divided by 4.98 minus x. Okay, 4.98 minus x. Now again, what is Kp they have given? They have not given Kp. Okay, they have not given Kp. Wait a second. I missed one thing. Okay, this is the equilibrium. This is the equilibrium pressure, right? This is the equilibrium pressure. So if I add these two, pressure of N2O4 plus the pressure of NO2, it is going to be equal to the P total. Yes or no, guys? Yes or no?
Yes, sir.
Okay. And what is the pressure of N2O4? It is 4.98 minus x plus NO2 is how much? Plus 2x. This will be equal to the P total they have given us 9.15 bar. So we have got something, and from here we can calculate the x, right? So x will be equal to how much? Here will be having x, it will be equal to 9.15 minus 4.98, right? What is the answer here? Tell me, guys. Calculate the x. 4.17. Okay. So this is x, and n2 4 is 4.98 minus x. Okay. Now you can calculate here 2 into 4.17 whole square divided by 4.98 minus 4.17. Then you will get the KP here. Then you will get the KP. Okay. And we know the relationship between KP and KC. That KP, sorry, no. KP, it is equal to KC times RT to the power of delta Ng, right? Delta Ng. Ng means change in the number of moles of gas. So in this case, you will have Kc, this will be equal to Kp divided by RT to the power of delta Ng. Okay. So you can calculate both of these things. Write this down. Let me know if you're done. Then we can move on to the next topic. The
A bit.
scroll up. Okay. Okay. Yeah. Sure. Sure. This table is most important. Okay. This table is most important. And this concept now you will be getting something from
That table.
okay, you're writing the table. And initial change and equilibrium, you will be given something from the initial, something from the change, and something from the equilibrium. Okay. And you have to look at the relationship between them. Mainly, you have to look at the relationship between some information from initial and change. Then you need to relate that to the equilibrium one.
Okay, sir, done. Could you scroll down?
Yeah, you can scroll down. Done, guys?
Yes, sir. Done.
Now, let me. Okay, fine. Do you have your NCERT text? Tell me yes or no. If you have, you must have the NCERT text. So please,
Yes,
can you
sir.
open that? Yeah. Okay, fine. And in the NCERT, can you go to equilibrium chapter, obviously, and example number 7.9. Acha, okay, is that okay? You get it? Yes or no? Tell me. 7.9. Page number it is, I guess, 208. 207, not 8, 7. Yes. मिला किसी को? Page number 207.
So 7.9, right?
It's 7.9. 7.8
Yes,
so we
sir.
just did. So can you see that question? In that you can see 3 mole of PCl5 is kept in 1 liter closed vessel. Was allowed to attain equilibrium at this much. Calculate the composition of mixture at Kc is equal to 1.80. Okay. Now in this question you can see that you have been given something initial. The reaction is there. PCl5 is giving you PCl3 plus Cl2. I hope you have seen this reaction. Yes or no? In chapter number 4, chemical bonding. While we were learning about PCl5, why it gets into PCl3 and Cl2, dissociated into PCl3 and Cl2.
Sir,
याद है कि नहीं
are you
आपको?
writing a question now? Or
No, I'm
showing a
not writing.
question?
नहीं, हम कुछ नहीं कर रहे हैं, हम आप लोग को बोल रहे हैं कॉपी में देखने के लिए.
Okay.
Okay, we have done that. Wait a second, let me show you. PCl5. See? Can you see this reaction? PCl5, PCl3 plus
Yes,
Cl2.
sir.
है ना? So this is coming in handy. Then you look at the notebook. Okay, you look at the notebook, matlab that textbook. Sorry, not notebook, textbook. So and you have been given something from the equilibrium. That is the Kc. है ना? That is the Kc. So this is the same type of questions you will be seeing. Okay, now you can go to question number 7.8 in the exercises. 7.8 in the exercises. Reaction between N2 and O2 takes place as follows.
Yes, sir.
So again, you have been given if a mixture of 0.482 N2 and 0.0933 mole of O2 is placed at 10 liter reaction vessel allowed to form N2O at a temperature for which Kc is given. So you have been given something from the initial. You have been also given something. You have been given the reaction, that is the change, and then you have been given something from the equilibrium, that is the equilibrium constant. The equilibrium constant, and then you have to calculate the composition. That means the equilibrium concentration of N2, O2, and N2O. Correct? Yes or no?
Yes, sir.
Then again, look at the next question, 7.9. You have been given the initial, yes or no? Tell me.
Yes, sir.
The change is there. Change is there na, because the reaction is given.
Yes, sir.
Okay, and then you have been given something from the equilibrium, yes or no? See, you have been given the number of moles of NOBr. है ना?
Yes, sir.
Okay, so see, this is the same pattern that you will be seeing in all the questions. But what you have to, we don't calculate the equilibrium concentration. We calculate the change, है ना? And the change itself is the equilibrium concentration. That is another case. So there should be some relationship between the change and whatever you are having equilibrium, and you have written the equilibrium in terms of a variable as we have written here. See this. So you need to look for this type of reaction somewhere. Okay, this is one thing that you will be seeing many questions if you have pressure. Okay, so here the equilibrium pressure and the equilibrium pressure of individual gases, you need to relate these two things. Okay, so you will be seeing similar type of questions. So your homework will be a lot of homework. Okay, you can do, if you start doing NCERT, then you can start with, I think 7.8 is the, yeah, yes, 7.8 to I think 7.23. 7.23. I think you can do these questions. Yeah, 7.23. So all of these questions, they will revolve around the same theme: initial, change, equilibrium. Okay, initial, change, equilibrium. You have to identify how to relate the change, initial change and equilibrium. And also, you know that initial minus change, it is equal to equilibrium, right? So there will be something given about that. You have to write that I minus C, and there will be some Kc or Kp or P total or some concentration at equilibrium. Okay, so need to relate this change that is variable. This change will be variable to any of these terms, whatever is given. You have to identify that. Okay, you have to identify that. Initial minus change will not be a problem. The relation between this thing and whatever parameter is given for equilibrium to derive a particular relationship, to think about a relationship, that is the creative part. Okay, that is the creative part that is going to think. If you simply get Kc, that is fine. If you get simply Kp, that is fine. But if you get P total, then you have to work around it. If you get the concentration, then you have to work around it. Okay. Otherwise, I'm here. I can tell you guys. So, but please try to do at least, how many questions are these? 16 questions. So please do 8 questions. Okay. 7.8 to 7. Let us 7.14 only. Okay. Do at least this much. Fine, guys. Tell me yes or no.
Yes, sir.
As homework. Okay, sir.
As homework. Okay. Okay, but by the way, in assignment ये सारे ही सवाल रहेंगे. I think in assignment you will be given all of these questions, but it don't worry, आपके पास एक ही दिन है. इस वजह से क्या कीजिए आप, at least do some of the question, half of those questions, then you can submit it later. Okay, around the week, the whole week, because tomorrow also I have to give you some questions. Okay, fine. So this is all about the application of equilibrium constant. Equilibrium constant के application हो गए. Now I will write some topics name that we have already written in the chapter, that is thermodynamics. The topic is relationship between delta G and K. Relationship between delta G and K. You know that delta G is equal to delta G naught plus RT ln Q for a reaction. If the reaction is proceeding, then this is the case. But at equilibrium, nothing happens. At equilibrium, nothing happens, and that is why the delta G will be equal to 0. There will be no change in energy. Okay, delta G naught will not be 0. It is not necessarily 0. Delta G naught is not necessarily 0, because that is when a reaction is happening at a particular condition. It is not equilibrium. Okay? It is not at equilibrium. It is not measured at equilibrium, delta G naught. But at equilibrium, delta G will be equal to 0, and the Q will be equal to the K, right? Because at equilibrium, Q is equal to K. It is a constant, and hence I can write 0. Delta G 0 is equal to delta G naught plus RT ln K, and hence I can write delta G naught is equal to minus RT ln K, minus RT ln K. Okay, now we can also write my delta G naught, it is equal to minus RT ln K. I can write minus 2.303 RT log of K. RT and log of K. Now, what is ln and what is log? Difference between those is ln is log to the power of E, and if I just write log, this is means log to the base of 10. Okay, generally it means that. And if I want to write about log K, that is log of base 10 K, this will be equal to how much? Delta G naught divided by delta G naught divided by minus delta G naught divided by 2.303 RT. And if I just want to write about K, this will be equal to 10 to the power of delta G naught divided by 2.303 RT. With those questions, do the question number 24. Okay, You can leave one question from there and do the question number 24, which is based on this. First, do this question. When you're starting to do the homework, do this question first of all, and then start with those questions. Okay.
Sir, could you scroll up a little bit?
Okay, fine. Done, guys?
Yes, sir, done.
Done, all of you? Is there anyone who's
Yes,
still
sir.
writing? What about Khalid?
Done, sir.
Done. Okay, fine. Now let us move on. Let us see what will happen. Now we have got everything about equilibrium. Okay, we have got everything about equilibrium. Yeah, we also know how to calculate the equilibrium concentration. Now we want to discuss what will happen if I disturb the equilibrium. We will disturb the equilibrium. Okay, we have A, which is in equilibrium with, let us say B. Okay. Now the equilibrium has been achieved. The equilibrium has been achieved. Okay. What will happen if I add in the system? Okay, what will happen? It means asking whether the reaction will go forward or backward. Okay, I'm just asking that. What will happen? Whether it will go forward or backward. Your answer should be it will go forward or it will go backward. If I will add some more A, what will happen if I will add some more A? Reaction will move forward or backward? What do you guys think? Tell me. If I will add some more A, yes, Hamza? Reaction will move forward or backward?
Forward.
Forward, it will move forward. Okay, so let us start getting some number. So initially I would say that the K was equal to 1. The K was equal to 1. And initially I had 5 moles of A and 5 moles of B, and hence the equilibrium was established. Okay. Then I added plus 2 moles of A. So A became 7. Yes or no? And B was still 5. Okay, Hamza, any problem, guys? Tell me.
No, sir.
No problem. Okay, fine. Then what will happen? Reaction will move forward. That means the amount of A will decrease. It will become 6, and B, it will become also 1 mole of B will be formed. It will become 6. Now tell me, will it further move? Will it further move forward, or will this reaction stop here? Tell me.
Let me stop here.
Stop here, right? Now you can see that. Now you should see one thing, that this addition was done by human, right? And this is the system, right? And A and B, this is the system. So human added A, and system, what did it do? Human added A, and the system, to establish and to keep the equilibrium in place, and to establish the equilibrium, what did it do? It decreased the A. Yes or no? Can you see this?
Yes, sir.
Okay, fine. That means whatever change we are going to, whatever change we are doing at the equilibrium, the system, it will try to minimize that change, right? So human wanted to increase the concentration of A. So system did something. System moved forward in order to decrease the amount of A. Okay, in order to decrease the amount of A. Now you can also see the same thing, that if I will increase the amount of B, what is going to happen? The reaction will move backward. Yes or no? Tell me, guys. Can I say that? Tell me. Now these numbers are just there, but in general we can say that na, if I will increase the concentration of reactant, then what will happen? Reaction will go forward. If I increase the product, then what will happen? The reaction will go backward. Any
Yes, sir.
problem? No problem. Okay, fine. Next is let us say about the temperature. Okay, let's talk about temperature. For temperature, what I need to do, I need to write here that let us say that this is, suppose that this is exothermic and this is endothermic. If this reaction A to B is exothermic, that means A is converting to B as well as it is giving out some heat. Can I say this? Tell me. I can write the equation like this, yes or no? Yes or no, guys?
Yes, sir.
Hamza, Hiba, Khalid, Nehra. You guys are understanding or not? Hiba, Khalid, आप लोग का जवाब नहीं आ रहा है.
Yes, sir.
You got it. Okay, fine. So Hiba, you will answer. Okay. Hiba, you will answer me. So Hiba, you say, if I am increasing the temperature, that means I'm heating the system, yes or no?
Yes, sir.
So if I'm heating the system, then I'm increasing the product. Listen to me very carefully. You look where the heat is. Tell me, where is the heat in this particular reaction, in the reactant or the product? Where is the heat? Product. Okay, fine. That means if I will increase the temperature, that means I'm heating the system.
Yes, sir.
That means I'm increasing the product.
Yes, sir.
Then what the system will do, it will want to decrease the heat, so it will move backward, right? Because I'm increasing something from the product, because heat was in product, and if I'm heating this thing, if I'm increasing the temperature, then what I'm doing, I am increasing this product, and whatever increase I'm doing, what it will do, it will go backward direction and it will consume that heat, because the backward is a endothermic reaction. Okay, endothermic reaction. That means I can say, if I have for exothermic reaction, if I will increase the temperature, then the reaction will move backward, right? And if I decrease the temperature, then the reaction will move forward. But for endothermic, if I increase the temperature, then the reaction, it will move forward. And if I decrease the temperature, then the reaction will move backward. Okay, so I have discussed with you two things about, first of all, the concentration and the temperature, right? Concentration and the temperature. All of these things, we saw that humans, it did something. Okay, so it disturbed the equilibrium. So what did the system do? System moved in such a way that whatever the change, now whatever the disturbance was there, in a way that disturbance was minimized. So you guys tell me, you understand this whole concept? Tell me, yes or no?
Yes, sir.
Yes, okay, fine. So this was given by whatever we just derived right now, whatever you understood right now. This was given by Lee Chatelier. Okay, Lee Chatelier, and he had this principle by his name. So you can see that it's not like a principle as in it does not have any logic. It has logic, and it can be derived by 11th standard students also. Okay, so you don't worry about these big names, you know, and please never learn them by their just name. Try to focus about what is happening inside. So factors affecting state of equilibrium. State of equilibrium means it is not affecting the equilibrium constant. What it will be affecting is the equilibrium concentration, equilibrium pressure. Because as you can see in the earlier case, we saw that the equilibrium was established at 5.5. But when we added A, the equilibrium was established at 6.6. Okay, so it affects the state of equilibrium. Now, all of this principle, it was given by Lee Chatelier principle. So first of all, let me write Lee Chatelier principle. Lee Chatelier's principle. Now I don't want to write anyone's quotations, so I will use my handy tool. Okay, so you can write this down. You can copy this thing down. This is the same thing that we have just learned. If a system in equilibrium is subject to a change in any of the factors that determine the equilibrium conditions of a system, then the equilibrium will shift in the direction so as to reduce or counteract the effect of the change. Okay. Now you have to think in terms of forward and backward, where the human interaction is taking place, where the human is interfering, where it is contributing to the disturbance, and how the system. So system can only do two things. It can move forward or it can move backward. So it will either move forward to reduce the change or it will move backward to reduce the change. Okay. So you have to think in those terms. So it is a kind of a creative process to think what will happen. To think what will happen. Done, guys?
Yes, sir.
Okay. Now, the first is effect of change in concentration. The factors affecting that. The first is concentration. You can just write the result because we have just discussed that we can either change the concentration of reactants, and in reactants we can do two things. We can either increase it. If we are going to increase the reactants, then it is going to decrease the reactant. The system is going to decrease the reactant by moving forward, because if it moves forward, reactants is getting converted to products and it is getting reduced. So if the human is increasing it, then the system will move the reaction towards forward direction. Forward direction. Okay, and if I decrease this, so if the human is going to decrease it, human means आपके हिसाब से questioner है ना, तो questioner बोलेगा ऐसे कि I am decreasing the amount of something. So if I decrease this, it is going to move backward. Backward direction. Okay. Then we have products. So in product, if I increase the product, then the system, it is going to decrease the product by moving backward. And if I decrease the product, then it is going to move forward to increase the product. No problem in this, na guys? Tell me. Hey, tell me, yes or no? Heba? What happened? Heba, Khalid?
No,
problem,
sir.
sir.
No problem, no? Okay, fine. अच्छा, do one thing. आप लोग हाँ, you have written the 4 cases, right? Forward, backward, वो आप लोग खुद से लिखिएगा थोड़ा सा ध्यान लगा के, ठीक है? It will also help you in retention. Otherwise, recording तो है ही आपके पास, है ना? You can ask me tomorrow also. You can leave space. Okay, you can discuss many things. You can do. Second is the temperature. Temperature. Okay. So for temperature, I can write. So I can only do 2 things for temperature.
Sir, can you scroll up?
नहीं. I won't scroll up.
No, like I just have to write the last line.
तो वो खुद से लिख लीजिए ना, क्या है लास्ट लाइन बताइए. What are we increasing? Tell me, Hamza. I will help you. What are we
The
increasing or
temperature.
decreasing? Temperature. Temperature तो ये लिखा है हमने ना, जो दिख रहा है आपको स्क्रॉल क्यों करवाना है ऊपर?
No, like just I have to write the last line.
हाँ, लास्ट लाइन ना, तो लास्ट लाइन से पहले क्या हुआ? रिएक्टेंट वाला है, प्रोडक्ट वाला है? बताइए, प्रोडक्ट वाला है. अरे क्या हुआ हमसा? प्रोडक्ट वाला ही होगा ना वो तो. यस.
Yes, sir.
प्रोडक्ट में हम क्या कर रहे हैं? आर वी इंक्रीजिंग द अमाउंट ऑफ प्रोडक्ट कंसंट्रेशन? हम इंक्रीज कर रहे हैं या डिक्रीज कर रहे हैं? बताइए.
Sir, decrease.
डिक्रीज कर रहे हैं, तो सिस्टम क्या करेगा? उल्टा करेगा उसका, है ना? सिस्टम क्या चाहेगा?
Yes, sir.
तो बताइए, तो आप प्रोडक्ट को कैसे बढ़ा सकते हैं? कौन से डायरेक्शन में जाके? प्रोडक्ट बनेगा तभी बढ़ेगा, है ना हमसा?
Sir, forward.
ये आपको हिबा बताई ना, हम सुन लिए. दोनों आप एक रूम में बैठे ना, हम तो सुन लिए ये बात. ये हिबा नहीं बताया ना आपको?
No, sir.
सही बताइए एकदम.
Yes, sir. Seriously, she's been telling me.
Did you not tell you? ऐसे हमको
Yes.
बैकग्राउंड से क्यों, ऐसे क्यों आवाज आ रहा है? ओके फाइन.
We are sitting very far away. Like, even if she tells, like, you won't be able
अच्छा,
to
ओके, नो
hear it.
प्रॉब्लम. ओके, मेरा कान वैसे बहुत तेज है.
No,
No,
but
I am just
seriously.
kidding. I am just kidding. Okay, fine. I am just kidding. But, now you know ना, फॉरवर्ड डायरेक्शन, ठीक है? ओके.
Yes, sir.
Okay, fine. Now in temperature, what will happen? We have temperature, and we can, if you have been given the temperature, we are increasing the temperature or decreasing the temperature. Then if I will increase it, then what will happen? The reaction will shift towards endothermic. Okay, shift towards endo. Now you have to see what is endo, forward or backward. Decrease, then it will shift towards exothermic. Okay, it will shift towards exothermic. Also, we can write things about exothermic reactions and endothermic reactions. For exothermic, the temperature, if the net reaction is exothermic, then I can say that the temperature can increase. Temperature is increasing, or we can decrease the temperature for exothermic reaction. Okay. Now, if I am increasing the temperature for exothermic reaction, then what will happen? If I am increasing the exothermic reaction and the temperature is increasing, that means it will go backward. It will go backward. Now, if it is going backward, that means what will happen? The concentration of product will decrease. Concentration of product will decrease. And because of that, in K, that is the equilibrium constant, we know that it is equal to the concentration of product divided by the concentration of reactant. Now, if the concentration of product is decreasing, that means the K will also decrease. The K is going to decrease. Okay. Now, if I decrease the temperature, then it will move forward. And product concentration will increase, and due to that, the K will also increase. Okay, the K will also increase. If I have an endothermic reaction, Then in this case, if the temperature is increasing, then the reaction will move forward. The concentration of product will increase. And due to that, the equilibrium constant will also increase. If I have temperature which is going down, it will move backward, which will decrease the amount of product concentration and which will lead to the decrease in equilibrium constant. Okay, so write this down. Let me know if you're done.
Sir, could you like scroll up also a bit?
Nine.
The temperature part. Okay.
No. Figure out yourself. है ना? If you have doubt, you tell me. I can discuss this, लेकिन छापना नहीं है आप. समझ में आया ना आपको खालिद? जी.
Yes, sir.
हाँ, तो समझ में आया तो फिर आप खुद से ट्राई कर लीजिए, है ना? Done, guys. ये सवाल करके
Yes,
बस
sir.
चलते हैं ना? ओके, देखिए अब बताइए आप लोग, है ना? प्लीज कीप योर माइक ऑन ना. हमजा, हिबा, खालिद, नेहरा, गाइस.
Yes, sir.
Okay, now see this reaction, है ना? You have 2 moles of H2 plus monoxide, which is giving you methanol. Just giving you methanol. Okay. Now in this case, addition, describe the effect of addition of H2. So you have to describe whether it will go forward or backward. This that. So I will ask you a series of questions. You just answer me, and you will be getting the answer. Okay. So addition of H2. So what are we increasing? Product or reactant?
Reactant.
Okay. So it will move what? Forward or backward?
Forward.
Forward. Okay. Now in this case, we are increasing product or reactant?
Product.
Product. So it will go backward.
Backward.
है ना? You can refer to your note. Okay. Removal of CO. So what are we removing? Product or reactant?
Reactant.
Reactant. So it will move.
Reactant.
Yes. We are removing reactant. So
Backward.
forward.
Backward.
रिएक्टेंट. अच्छा नहीं सोचा ना ऐसे याद नहीं होगा, कभी भी याद नहीं होगा. ठीक है, ऐसे रिएक्टेंट को फॉरवर्ड मत कीजिए. सो थिंक अबाउट इट थोड़ा, हमजा. लेकिन यही केस है, फॉरवर्ड नहीं के बाद बैकवर्ड हो जाएगा. आप बोल दीजिएगा बैकवर्ड. टेल मी हाउ बैकवर्ड, बट व्हाई बैकवर्ड? ओके, अगेन सो दिस इज अ लॉन्ग थ्रो, बट स्टिल थोड़ा सा ना यही कंसेप्ट को आप लोग लेके चलिए तो अच्छा रहेगा. That if you are in doubt somewhere, then always confirm it by telling that human is, what is the human doing, Hamza? It is removing the CO. So it is removing what? Product or reactant?
Reactant.
It is removing the reactant, yes or no?
Yes, sir.
Yes. So what will be the system doing? It will be increasing the reactant or decreasing the reactant? System?
So decreasing.
नहीं, ह्यूमन क्या कर रहा है? इंक्रीज कर रहा है, डिक्रीज कर रहा है रिएक्टेंट को? व्हाट इज द ह्यूमन डूइंग?
Increasing.
नहीं, रिमूवल है ना, रिमूवल ऑफ CO. रिमूवल, व्हाट हैपेंड, हमजा?
I'm a little confused with this removal.
Removal means what? Tell me.
To subtract something from.
So it is increase or decrease?
Reduce. Decrease.
decrease. So this is all the things that is describe the effect of. Na? That means the humans are adding H2, adding